Okay, if you have a Ti-nspire calculator, please grab your notebook and a pencil. Take notes on which buttons I'm pressing because it's a little bit of a lengthy process so that you can remember in class tomorrow how to follow this process on your own. If I want to find a function, and we've already decided I need a regression function because the data doesn't fit a perfect model. There's no same rate of change every time. The first thing you need to do is add the data into the spreadsheet. So to go down to this aqua thing, it says lists and spreadsheets, press enter. We're going to put the X values in the first column. Again, we changed that year to be years after 1980. I'm just typing in the numbers and pressing enter after each number. Then scroll up to the second column. We're going to add the Y values. Now, I have to give these columns a name. So I'm going to call this column X using the letter key. Now press tab to get out of that box. You should see the box B highlighted. I'm going to call these my Y values. Again, press tab, make sure you get out of that box. Any other box should be highlighted. Now let's take a look at a graph. Press home, scroll down to purple, add data and statistics. You'll need to scroll down until you see a rectangle appear. You're going to press enter and make your x-axis there. Make your y-axis here, and your data should appear. Again, we're seeing that the y values decrease and then increase, so not a line, but a parabolic shape is formed here. So if we want to write that regression function, let's go back home, go to our data, it should be entered here, and then press menu. We're going to calculate statistics, stat calculations, and you can choose the type of regression you want here. In this case, we want quadratic because the data looks parabolic. The X list, you can scroll through, choose X, Y list, scroll to Y, and then press OK. Here is your regression right here. So the equation, the title is Quadratic Regression. The equation, it's ax squared plus bx plus c. You can see it in this little yellow box. That's giving you the template. Now we know that because that's standard form of quadratic function. But if you forgot where to put everything, you're essentially taking a, b, and c, these numbers they calculated, and putting them into this yellow template or formula. So our equation is going to look like this. Y equals a. Well, a we can round to 0.004. I'm writing the function down right here. So ax squared plus b is this number. Oh, so just minus 0.094x plus c. So plus 2.607. Again, where x is the number of, X is the number of years since 1980. Let's make sure we fully answered this question. Find a function that models the data below. Here's my function. Justify my choice of function. We used a regression function since the data did not perfectly follow a pattern, or to say the rate of change was different between some of the y values than other y values. We used a quadratic regression function since the y values decreased and then increased. That's to say it didn't follow a linear pattern. The y values didn't strictly go up or strictly go down. Okay, one more example for us today. Again, our goal is to write an equation of the function. So let's take a look at what's happening with these y values. I can see they're decreasing. Here they're decreasing by about 15. Here by about 10. Oh, here they're decreasing about 17. So they're decreasing, but they're not decreasing by the same rate each time. So let's write a regression function. We'll recall x to be the number of minutes after 10:13. That way we're just dealing with easier x values. So we can, this would be 2 minutes after 10:13. Oops. So let's give these x values new values. Okay, so we're going to do the same thing. Go ahead and delete or save if you want as a different file the data you already have, because we want to start fresh. I'm not going to save it, but you can if you want to. That way, if you have questions in class, we can look at the data you actually typed in. Feel free to save those documents if you want. Okay, let's type in our X values, the easier to work with ones. Type in our Y values. Give these columns a title. Again, I'm just going to call them X and Y. I'm pressing Tab to get out of these boxes. Let's look at a picture of what this data looks like. Add my X-axis and my Y-axis. Okay, it looks pretty linear to me, honestly. But maybe you don't really remember what exponential functions look like, or maybe you're thinking, well, here the rate of change is quicker, here it's much slower, maybe it looks quadratic or exponential. Here's how you can decide what the best function will look like. Go back to your chart and we'll try a couple of them. Okay, let's calculate a linear regression. I want my X values. And my Y values. Oops, sorry about that. Let's try again. Works better if I use the drop-down menu, I guess. Okay, take a look at this R² value. The closer R² is to 1, the better your function represents the data you're shown. So I'm going to jot this number down. The linear regression has R² equal to, let's round this, 0.986. Okay, now let's try a different kind of regression and see what that R² value is. Let's try a quadratic. Okay, so quadratic function is going to have an R² of 0.9896, so 0.990. Let's jot that down. Because this R² value is larger than this R² value, a quadratic regression better fits the data. We have one more to try it. Let's try an exponential regression. Scroll down. I gotta find that R². Here we go, 0.988. So this is actually the best R² value. Oh, I'm sorry, 0.990 would be better. So the quadratic regression would be the best choice of regression. So let's use f of x equals, and we'll go back and take a look here. The regression equation, again, is ax² plus bx plus c, so we need to find those values. 0.148 x² plus, minus 8.249 x plus 180.129. Let's make sure we answered our question fully. Write the equation. Again, we chose a quadratic regression function, since the quadratic regression had a higher R-squared value than the linear or exponential regression, meaning that the quadratic regression better fit the data than the other regression models. Okay.